All right, thank you very much. Thank you very much for guys for coming down today for K8SUG 27 meetup. The overall number is 27 meetup. Since the time we started, we have grown exponentially, and from last month we have also grown. We have done a first meetup in UK, and soon we are also going to start it up in some other European regions as well. For now, the stats are like we have 2,800 plus meetup members, 5,000 plus global meetup members, and 5,000 plus LinkedIn members. So today's topic, we have two topics. So usually we do three topics, but today we try to see that, we'll change some format wherein we will keep two topics and we'll keep the two topics, give more time to the speaker to address the questions and go more into insight. So we have first Kris here, solution architect from Alibaba, who will be speaking the first topic of Kubernetes for gaming, Metaverse with Alibaba, OpenKruiseGame. Second, we have Vishnu Dadhich, who would be talking about the troubleshooting companion, and it's an interesting topic, K8SUG. I would like to thank our main sponsor, CNCF, Core Cloud, and Alibaba. And Alibaba Cloud is our venue sponsor for today, and they have generously provided with the foods and drinks. So I would like to thank Alibaba, Steve specifically, who had made sure that we would be able to have this venue for today's event. Thank you, Steve. So meet our team. Our team, so we are the three core. Yongkang is the founder, me and Fazil, we are the co-organizer for Singapore and other regions as well. And with me, I have a team of volunteers and co-organizers, Ram, Siva, and Fatima. So these guys, all six of us, we try to make sure that some of us are available every month to schedule the event, and then on the day of the event we facilitate everyone. So thank you for my team for their help and support. As you know, we always say, and even now, if anybody who is interested to join us as a speaker, as a community speaker, please scan the QR code, register yourself, give your topic, and we will reach out to you. If you want to be a volunteer, you can scan the volunteer QR code and join us. And if you know someone who would like to sponsor us, like how Alibaba did, so let them know, or you can stand and nominate yourself as a sponsor, and we would be happy to reach out to you guys. All right, with that, I will end my small presentation and I will hand over to Kris. Kris is a solution architect from Alibaba, and he would be discussing on the topic, which I have just downloaded, and let me open it. Yeah. All right. Please welcome Kris here, solution architect from Alibaba.
Hello everyone, and I'm Kris here from Alibaba Cloud Internal Service team. And today I would like to talk about a new tool approach that I have been working for 2 years that will help you to run gaming Metaverse applications and more on Kubernetes. Okay, and before the introduction of OpenKruiseGame, that I would like to have an retrospect of how the Kubernetes game is adoption in different applications. So you know that as Kubernetes have been run for about 9 years. So in this 9 years, we have seen that many applications have been have adopted Kubernetes as a deployment method. So at first beginning, we see that when the Kubernetes came out, actually there are still a lot of monolithic applications that are running on our users' environment. So at that time, but actually at that time, there's also a trend that to refactoring the applications into microservice application. So actually, the first adoptions of Kubernetes actually happens in the microservice application. So because it's quite straightforward to deploy them into Kubernetes and gain the benefits of Kubernetes. And actually, I think that Kubernetes is firstly designed for the microservice actions. So that's why the CloudCasa is the first great adoption in the microservice applications. And then we find that after Kubernetes microservices that many of our customer users are starting to deploy their applications into the Kubernetes clusters. And I think it's a little much more challenging for you to deploy state application in the Kubernetes, but it's not impossible. So, but you need some industrial or some expertise on it. So you are expertise on Kafka Redis and maybe database, and also you have a good understanding and skills on Kubernetes that you can deploy this kind of application in Kubernetes. Not a problem if you have both the expertise on Kubernetes and those state applications. And next thing is that the big data and AI. We've seen that in the last 3 or 4 years, our customers are starting to deploy their big data and AI workloads into Kubernetes, especially in some educational autopilot companies. They are training applications in Kubernetes and they are deploying and serving their AI workloads in Kubernetes. That's the trend that we are seeing in the big data and AI. And what's next? What we're thinking about is that so microservices, data apps, and big data and AI, those kind of workloads have been deployed to Kubernetes. And there's one missing that Kubernetes kind of some general purpose workload automation. So when you apply the Kubernetes pattern to some quite unique in the industry or some maybe weirdo thing that it may you find that's not we cannot fit this kind of application into the Kubernetes. And on our cloud, we see that we know that there are many gaming industry, there are many game companies in China. So we are on our cloud, we see that there are many gaming in the industry game users are starting to deploy their gaming into the Kubernetes. So I would like to begin with gaming microservice use case. It's a diagram architecture come from one of our customer on Alibaba Cloud. And actually, when we're talking about games, many of you think that microservice and gaming is quite different. They have no relationship between each other. But actually, in Chinese gaming company, they are the same. So in China, they are turning most of their business gaming system into microservices. So this company just breaking down their gaming system into 2 parts: the stable one and the stateless. The stateless are quite it's an ideal deployment into Kubernetes, but while the stable one, they have encountered many challenging things on stable applications, especially at the core of the center, the game server. Because the game server is quite different from that of the microservices that when you deploy them into Kubernetes and containers, you have to there's many patterns that cannot fit into the Kubernetes. So before we were talking about the pattern that we are developing for the gaming workloads, with what I want to talk about how the game server are deployed in virtual machine. So for many years, the gaming architecture is quite flat. So gaming developers usually put those login, chat, battle, working, those kind of business logic into one process. So to make it to be deployed in the virtual machines. So you deploy and many scenarios, so these different game server processes are deployed in the one single virtual machines. And so there may be resource contention between these processes. And but still, this kind of pattern works on virtual machines. But if you apply them into containers and Kubernetes, it poses challenges. And next thing we will talk about, so if you have something against server deployed like this in virtual machines, the first thing we're consider about how to containerize the application. Actually, there are two ways to do this. The first approach quite straightforward, just write the whole process into and package it into just one container image. Quite straightforward. You don't have to modify any code again. And the second approach is that maybe if you can take some logic out of this process and make them into microservices. For example, login chatting, so you can make the business gaming logic better working into just one process and make this process into as a game server. So both approaches will work fine on OpenKruiseGame. We'll talk about like that. You adopt the first approach and change nothing, and OpenKruiseGame can help you to containerize them and just run those run them with Kubernetes. Run them on Kubernetes with OpenKruiseGame. And if you do it like this, it's all right. So both approaches will be working on OpenKruiseGame. Okay. We are talking about when you containerize those game server, then next thing we are going to deploy them to Kubernetes. It's quite straightforward because you have the container image, you want to deploy them, you can create some manifest of Kubernetes and deploy them. Quite straightforward. But actually it's not, because the game service quite have some unique characteristics that are quite different from that of standard Kubernetes deployment services. So we cannot just simply put them into the Kubernetes. For example, the first thing that came up with that is the hot update and reload. Many game servers, almost maybe most of the good game servers that deploy virtual machine, they always I need to update something and the process needs to reload some config, reload some environment and config of that server, and while there are still active players playing on that server. So we need to update those configurations and reload with that configuration while players are still running and playing on that game server. So that's a challenge to Kubernetes, because you know that the life cycle of pod and containers are consistent. When you update something, the container will be replicating. Those interrupt the player experience. And the next thing come up to us is that you may need some direct measurement. So there's a famous analogy about cattle and cans. So the game servers maybe it quite like some pets, and the pet is carefully handled and taken care. And when the cat gets ill, and you just take care of them and help them to nurse them back to the house. But for cattle, it's like those Kubernetes pods, they are identical, and when those cattle gets ill, you replace them with another one. Okay, but it seems like unfair to those cattle that they're killed too, but okay, it's an analogy. So anyway, so if you compare to the game server to the pets, so this game server still looks like those pets that need to be taken care carefully. Okay, so sometimes, while you found as an example, you have to modify something on that particular game server. You cannot just delete them or replace them with another one, because they're still active players working on playing those game sessions on this one. So that you cannot just delete them or replace them with another one. So you can just isolate this. You should isolate this one and do something and bring it back to health, and then isolate them from the cluster so that the user can connect again. And the third thing that coming up that is compared to running themselves on virtual machine, that the container pods will be scaling all the time. It's not on the virtual machine. They have fixed IP and port. You can always connect to the virtual machine. But for container pods, maybe for a few minutes an hour, the pod always scaling things. So we cannot connect the IP and such as like that in virtual machine. So the thing is that, and that's the thing that we need the automation of networking so that we can always map the container part to the outside world, to the client, to the game players, that they can connect to the game server with the fixed IP and ports. That's the automation simple. And another thing about the high performance. And actually, traditionally, there's still many game companies that deploy a process before the game server, so that they can have some fixed IP address and domain name, so that they connect to the game server. But with container and with this automation, so you can connect to the game server directly to the game server without any process. So it's processless and it has high performance on this. And the fourth thing about that we're talking about containerized game servers. The one of things that we want to do is that to auto-scaling the game servers. So the game is quite a serverless scenario. So in different times during the day, it need different server resources for these game servers. So in the peak time, maybe you have to scale your game servers to serve your game players, but in the off-peak time, then you have scaled down your applications. When we think about that, the Kubernetes has HPA auto-scaling, horizontal auto-scaling thing for this, but for scaling down, HPA cannot work in this kind of scenario because there may be still, for example, you have 6 game servers, there's still some players that they're working on them and playing those sessions on them. So you cannot just randomly delete those game servers. So you have another way to scale down the game server cost. So maybe you came out with some event-based scaling process, or you have some sequence control to how to control the starting up and shutting down of the containers inside the pod. And maybe also we can also try something customized QoS to let the Kubernetes know the status of those game servers, so that the Kubernetes can decide whether to reclaim and delete those game servers. So that's those 4 things that when we're trying to address this the problem that we're trying to do on Kubernetes. That's the 4 questions when we want to do this. And next thing I want to talk about why running servers game server is not out of fun. Maybe at the beginning, actually, my college is out of fun. Maybe we can try something fun. We run game servers on container initially. But if when we decided to do so, we're thinking about, okay, actually it's not out of fun. We have to provide some quite core features and functionalities to help our customers actually benefit them from running game servers in Kubernetes. So actually, game servers in China, game customer. So game server have always been an outsider of the Kubernetes world. They want to containerize their application, but they have so many terrain that they cannot deploy them in Kubernetes. So the first thing is that we want to create something to standardize the deployment, the game DevOps of the gaming workloads, and help them to manage these game servers just like managing those microservices. So that improve their DevOps efficiency. And more importantly is the electricity. So actually many game servers when deploying virtual machine, the electricity, you can do the electricity when deploying virtual machine, but it's quite low efficient and engaging a lot of work on this electricity when you deploy it into virtual machine. But with Kubernetes, so Kubernetes is efficient and it's quite good at the electricity, and maybe we can add something, we can have some new feature that can enable the game server being auto-scaled by Kubernetes while keeping those players still running and still playing those games without interruption. So 2 years ago, 2 colleagues and me, we are thinking about, okay, many of our customers are trying to deploy those game servers in Kubernetes. They encounter many challenges doing things, so they cannot do this. So we are thinking about this, and at that time, we have already a project called OpenCruise is our CNCF sandbox project at that time in CNCF, and we are thinking of a new CRD, a new controller designated for the game workload. So we start to develop a trial project out of OpenCruise project to designate for this kind of workloads. And the purpose of this stack is just a new one, just a new workload controller to help those game servers that running on virtual machines. We don't have to change anything just drag them into content image, and you can benefit from the auto scaling, benefit from the automation and management tools that provided by Kubernetes at the same time. So that's our goal for this. So we're working on this for 2 years, and OpenKruiseGame is the outcome of our work on this. So it's a trial project from OpenKruiseGame. We decided to open source it to the CNCF, and then by integrating with Alibaba Cloud and other clouds, so that you can deploy the OpenKruiseGame in different clouds and even on premises to run your game server workloads. And it provides a bunch of features that we have talked about to help you to run game servers in Kubernetes. Let's take a look at the key features of OpenKruiseGame. I will explain them one by one. Actually, I divide into PvP session games or PvE zone, but actually some kind of games cannot be divided into these two types. But some of games maybe have some kind of feature that are more similar to PvP, and some of games maybe they are quite more similar to the PvE game. So this affects a rough separation. So but it's for the introduction, I think it's quite more clear. We will just divide it into two kinds of games, PvP and PvE. So for PvP games, quite session-based, comments in that where battleground and players get into the playground and do some battle, something like that. So this kind of session games, the game server lasts for maybe tens of minutes or maybe 1 or 2 hours. So those games so actually runs only 1 or 2 hours. So the auto scaling thing can help them to auto scale those game servers, because it runs only for 1 or 2 hours. You don't need to long run those game servers in the cloud computing sorting. So we have this auto scaling thing. So the Kubernetes can probe the status of the game server and decide if it can be deleted or it's in a normal state, you cannot do anything to them. So the OpenCruise Pro can help you to probe the status of the game server, and you can get those status via the Kubernetes status, and then the Kubernetes while the event-driven or scaling can drive your scaling of the game servers. And for auto network management, so the PvP session-based games, most of them you need to be direct connection to the client or client. So basically you can use the IP address or social balancer to connect to the game servers, and the OpenKruiseGame will help you to make sure that the IP address and port are quite fixed. So even maybe your game servers are recreated, the IP port and IP address and the port will always be fixed, and your client can always connect to this IP and port to connect to the game server. And matchmaking, you may know that there's a Google open source matching project called OpenMatch, and we have been integrating with OpenMatch to help you to, if you are applying some OpenMatch function, okay, so the OpenMatch can help you to get the IP address, get the networking metadata from the OpenKruiseGame director, so he can get in the connection information from the matching. And when the OpenMatch done the matchmaking, it can respond to the client with those OpenKruise connect information, so that the client connect to the game server or the battleground of that container pods. For the PvE zone game service pipeline, we run a game server relatively long, maybe a few days or months for that zone game server. So in this kind of scenario, because the game server running quite long and during those gaming in progressing, so the maintainers may need to update some of the configuration of scripts of those game server things. So you need to update the container without recreating the whole container pods. So this is a feature we implement in the OpenKruiseGame so that you can, while serving your players, while changing some config maps, so the scripts and configs that by in your game server process. And combined with a customized service quality we just mentioned about here, that the Kubernetes OpenKruiseGame can throw the status of your game server so that the game server status can be actually a status of Kubernetes, so that the Kubernetes can drive this auto scaling and this direct management thing for your game server. For example, maybe you find that one of these game servers there's something wrong with it, or they always uneven traffic here. Maybe some of the game server may have more player traffic here, so you find that it's going to break out. So maybe you need to increase increase the computer resource for this one game server. So you can just isolate the game server from the group and just manually increase the computer resources. For standard Kubernetes cannot do that because for deployment of that, if you change the specification of the deployment, it changes all the container pod. For OpenKruiseGame, you can have this direct management just to manage the game server that is specified and not affecting all of those game servers. And for those zone servers, you may need all the star of containers in container pod. So in most of the scenario inside this container, so you have not only one container, you have some container game engine and some script and maybe more container inside one pod, and they have the dependencies inside these containers in the container pod. So you may need all the sequence of starting and shutting down all those containers inside one pod to make sure that the gaming logic works for your games. It happens a lot in many of our customers that they need this all style containers. And during for game server, for PvE game server, there's also a procedure called game server merging. Maybe your game has been deployed for 1 year or 2 years, so that's maybe the life cycle of the gaming a new game server comes out. Maybe you run them for 1 or 2 years, so that's less and less user players are getting into this game. So you need to scale down these game servers with this control game server merging, so that you need to migrate those players into fewer game servers. So we offer this kind of game server merging features to help you to scale down your PvE zone server games. And we have we can have two case study here. One's called Latest Games, is a Chinese game company, and OKG helped them to deploy the TBS game digital to the Kubernetes on Alibaba Cloud, and can help them to increase the efficiency by 50% and reduce the operation and maintenance. Because they are running dozens of games in their company that develop dozens of games there, so they deploy all their games with OpenKruiseGame into Kubernetes. So all their SI teams only they care about the Kubernetes and the maintenance of those OKG and Kubernetes clusters. And for Hypergrass, it's another famous game company in China, and they deploy their MMORPG Arcanine into the Kubernetes with OpenKruiseGame. And basically, they are running some PvP room based game servers, and they use the auto scaling for their room based game servers. And last slide, I want to talk about the OpenKruise. I have mentioned about OpenKruise actually is the parent project of OpenKruiseGame. We create this OpenKruiseGame for gaming out of this OpenKruise project. And actually, the OpenKruiseGame focus on the world automation and resilience can help you to, especially it is designed for production and especially for some less complex application and some weird application that cannot fit your application into the standard Kubernetes, and OpenKruise is designed for those kind of complex and weird applications that help you to these outsiders of the Kubernetes work into the Kubernetes and help you to run them unified with Kubernetes way. And so OpenKruiseGame offer many autonomy capabilities to help you to run this kind of applications. And we create OpenKruiseGame based on the OpenKruise. Maybe you can create your own OpenKruiseGame based on these autonomy capabilities of OpenKruise. Okay, I think that's the all for the OpenKruiseGame and OpenKruise. Thank you everyone. Thank you for your time.
Thank you, Kris. Thank you very much. So
hello. Hey, am I audible? Yeah. Yes, I'm. Hello and welcome to the second session for K8SUG group. My name is Vishnu, and today I'm going to talk about K8SGPT, your troubleshooting companion. Yeah, so my name is Vishnu, and I'm working as a platform lead for Srijan. I've been in the industry for almost around 7 years now, and my core responsibilities are to create resilient infrastructures for a variety of workloads on data centers as well as public clouds. Feel free to connect me on LinkedIn. Yeah, I'll just wait for 2 minutes. All right. Yeah, so the borderline is, yeah, I work with Kubernetes as much as you all are working with Kubernetes. That's why probably you're here, or you would want to work with Kubernetes, that's why you're here. So I work with Kubernetes. Kubernetes is the de facto standard for orchestration, orchestrating your containers, and probably by now 90% of the workloads that are using containers are using Kubernetes, right? But with Kubernetes comes a plethora of issues that needs solving, right? So Kubernetes is not it's not easy. It's a bit complicated, right? It has multiple parts moving. Your application itself is a microservice that is deployed on your Kubernetes. That is also a moving part. So it's not easy being in a cluster and then building an application. So in the end, what you do is you troubleshoot, right? And troubleshooting is a bit hard. Yeah, we use Kubernetes. We in hope that it will ease our operations, but does it really ease our operations? This is one of the meme which I really like. I found it like months back, and I got time. Now is the time to put it on the slide. So yeah, yeah. But even though we have a lot of issues in Kubernetes in the operations, the first step is basically to check the status of your pods, your any resource, right? So whenever you have an issue, you just do kubectl get pods, right? Just to see like if your pods are up and running or not. Secondly, if your pods are not up and running, it's in pending state, what you do is usually describe the pod, basically check the events of that particular pod. Or let's say if you're using a percent volumes, you simply describe the percent volumes and go all the way bottom to check the events, right? So you usually do kubectl get pods, get events, and if you know like your pod are up but it keeps on failing, then you usually do kubectl logs to check the logs, like why what is failing. So even though the troubleshooting is hard, but 80% of the time or 90% of the time you will see yourself running these commands whenever you see a lot of issues, right? So what if like someone can automate these steps just to give you the first level of troubleshooting, first level of SRE that usually you end up doing every time. So yeah, then we have a tool right now. It's an open source CNCF sandbox project, which is K8SGPT. So what K8SGPT does is it analyzes your Kubernetes clusters and it gives you a result based on what is going wrong in your cluster. Not just that, it has the capability to connect with your AI backends like OpenAI, local AI, Azure AI, to give you a human language output of what is wrong and how can you resolve it in a very precise manner. Yeah, so why K8SGPT is special because it has codified SRE knowledge inbuilt into it. So whenever you do K8SGPT analyze, your K8SGPT will go and analyze your clusters in each and every resource. Currently, there are a bunch of analyzers available by default, like a pod analyzer will analyze your pods, a node analyzer will analyze your nodes, similarly PVCs, and a bunch of other analyzers are by default there, which helps you analyze the cluster and then give you an output. Currently here, if you see the GIF, you see says ---- explain. So whenever you pass ---- explain flag to your K8SGPT, it goes ahead and select the backend that you have configured with the K8SGPT, and then it will first analyze your cluster, and based on the results that it has got, it will talk to your K8SGPT. Okay, anyway, I'll show you a demo. I hope this is visible. This is not visible because this GF is small, but I'll show you a demo. So not just that, it will first K8SGPT will analyze it. It will create a bunch of outputs, and just that output is okay, right? It's not okay for a human to read and then understand unless you are an administrator, of course, but it will give you a detailed problem statement that you're having, and also some options, some ways to fix it. So when I say codified, it's actually codified, which means this is an open source project, so you can obviously see the code base on GitHub. So if you see, they have actually coded that, okay, if the PVC status is pending, that means you have to check the event, like what is the reason why it is pending. If it is provisioning failed, it then creates a sort of a message around it that says that, okay, the PVC is in pending state because the provisioning has failed. Now, this much, your K8SGPT will still analyze and do all the things, but it will again connect to the LLM only when you ask it to connect, right? So K8SGPT will still has the capability to analyze your Kubernetes cluster. So I'll just give a brief about the architecture on how the architecture looks like. So as I mentioned, your K8SGPT comes with a bunch of analyzers. Your analyzers, like for example, here we're talking about a pod analyzer. A pod analyzer has a list of checks or test cases, you say, like it does a pod list. If it sees that, okay, all the pods are up and running, okay, next test is to check all the events of your pods. Next test is to check the status of all the pods. So it has all sort of a unit tests to test your pods, or in case of pod analyzers, and it does that by talking to the Kubernetes API server, right? And once it has got all the results, it builds the results. But then also, if you have chosen to talk to a backend AI, so you will have to connect an AI provider, which could be your OpenAI and or your local AI, Azure AI, and then your AI provider will ask for the details based on what you have chosen. For example, OpenAI will talk to your model which you have chosen, like for example, GPT 3.5 Turbo, GPT 4. And then once it has got results, it will club up all the results and show you in the UI. Sorry, not UI, but in the CLI. Yeah, but we don't only have a K8S GPT CLI. We also have a K8S GPT operator. So K8S GPT operator runs inside of your Kubernetes cluster itself. You just need to provide some secrets to connect to the OpenAI server or any server which you want to connect. And then your K8S GPT will help you deploy a K8S GPT deployment. And the K8S GPT deployment is in itself, it has the capability to analyze. So it will go ahead and talk to your Kubernetes API server, it will keep checking the status of all the resources, and also it will keep talking to your API every, let's say 15-20 seconds. So as long as you have that, it will keep reconciling, keep checking that, okay, I have an issue, I have a pod that is not up and running, and then it will show the results in the Kubernetes cluster itself. So it creates a custom resource called results. So when you do kubectl, you'll get results. You'll see the results that Kubernetes GPT has prepared for you. And when you describe that result, you'll see the same output as you see in the Kubernetes CLI. So yeah, it is by default available, and you can directly deploy it on your Kubernetes clusters. You just need to provide it a secret, connect to an OpenAI. All right. Time for demo. I guess demo will be a bit more interesting. Let me. Dadhich, I need help. Someone hold the mic. Yeah, it's okay. You see the demo. Can you have 2 chairs for him as well? That would be better. Yes. So I hope you can see the screen, right? Screen is visible? Yes, thank you. So
Those behind, you guys can come ahead. Take a chair. And sit there. If you want. The moment. Last row. Can you see? No? Is it? I know it's not visible. So you guys can come. 3 people can come and sit. From Zoom. This is okay. I think yes, this is okay.
all right, so the first thing that you usually do when you have K8S GPT, you install the binary in your system. Currently, I'm just demoing on how you can use the K8S GPT CLI. Once you have the K8S GPT CLI, you will add the authentication for the OpenAI. By default, it is OpenAI, but once you have it, you add the API key. It's not shared. It's already sharing. It already says, okay, let me stop again and share it.
Yeah.
That's better, yeah. All right, so yeah, once you have the K8S GPT installed on your system, you just add the OpenAI key. To generate the OpenAI key, you need to have a OpenAI Plus account, and then you can generate a key. They have some rate limits, but yeah, I mean, you can do that. Once you have the key, you can simply, sorry? 3.5 will not work. It will work, but still you to have the access to the API, you will still need an Plus account. So here, when you add an OpenAI key, once you do kubectl, sorry, K8S GPT auth list, you will see that your OpenAI is active and OpenAI is the default one. So now I can actually use K8S GPT on my local with the backend OpenAI. So what I'll do is I'll just deploy an Nginx image and let's see. Okay, so I have deployed an Nginx image, but currently it says it has an error. It is not working. It is showing an error, which status is error. So now if I do K8SUG and I do analyze without explain, it says no problem detected, but it will take a little while to detect. Let me try it again. Yeah, now you see that it has detected that there is one issue. Your pod name is not running, but it says that AI is not used because we have not set the explain flag. But it is still can analyze and show you the results based on its own codified knowledge. Now, if you want to understand like what is the issue and how can we remediate it, you can do explain. And then -c is to make sure that the results are not cached. It's a brand new result that is coming from the OpenAI. So you can see it is now connecting to the OpenAI and it has connected and given the output. Now you see the same output, same errors, but now you see the error in a human format, human readable format, and also some solutions that could resolve it. So for example, here the pod was in error state, right? So it says that check the logs of the container of the pod and identify the specific error, because still it cannot go inside of the logs and then do that, but it can tell you the what can be the initial steps that can help you fix it. And then you have to fix the error and then update the deployment and then monitor the pod again. So it is a very easy and very simple steps that it gives you. It is very basic steps. It's still but a very good way to make sure that you are doing that. It is doing the first set of troubleshooting for you. So now not just that, it can also give you a little bit of the Kubernetes documentation as well. So if I do with doc, it will do the explanations along with the Kubernetes doc, which I don't see here. Usually it is here. Let me check again. Okay, I guess I don't see it here. Okay. Usually when you see within do with doc, you find a small link, a small one-liner statement of what could be wrong, but I don't see it here. Okay, no problem. We'll move forward for now. And then one more interesting thing is you can do an interactive session with K8SUG. Like for example, I have asked like, okay, this is the error, and it has given me some solutions to it that could fix it. But again, it has open an interactive mode, just like a chat GPT, right? So now I can ask like, okay, how do I restart a pod? So you see, it has now gone and asked the OpenAI on how to restart a pod, and it has given you small instructions on how to restart a pod just by getting the name of the pod and delete pod, and then Kubernetes will automatically create a new pod for you. So it's a very simple and basic example on how you can utilize the K8SUG for the first level of troubleshooting. And now you can exit it. So one more thing is like now you will be maybe worried that, okay, my Kubernetes pods has a lot of data which is internal, right? It needs not to the Kubernetes pod names, etc. should not go to the OpenAI servers. So there's also an option for anonymizing it, which uses anonymize flag. So I can do the same thing, but with anonymize. So what it will do is it will not tell the name of the pods exactly to the OpenAI server. And here you see that there is no name of the pod that it says. It will just tell that, okay, there's an anonymous pod that is failing. And that's how you make sure that it is anonymizing. Although it is not 100% anonymized, it might still send the list of events, and that events might still have the name of the pod or container. So yeah, I mean, it's still in development, but yeah, it could be a cool feature, let's say in coming few months, where it can stay in your local, stay in your private cluster, but it can be anonymous, and the results that it asks can also be anonymous, but you still get the output. Now, not just that, your K8 GPT also has some filters which allows you to output only certain resources that you would like. Like for example, here I am showing the list of filters that I have. By default, it automatically analyzes your ingress, replica set, person volume, pod, deployment node, and you can always enable the other ones as well, like gateway, HTTP route, HPA, logs, etc. So once you have enabled the filters, you will only see those outputs in the results. So for example, if I do analyze, but if I do only explain, okay, it's not showing me output. So currently it is showing one output for the pod, so I can always use filter. It will only show us the filters for the pod, or if I do deployment, it will not say that, okay, there's no deployment because there's no error in the deployments. So yeah, you can use filters based on what exact output do you want. And there's one more thing interesting in K8 GPT is that it is not just using the by default integrations that it has. It has also the ability to add some integrations. Like by default, it comes with Trivi, Prometheus, and AWS. Trivi can help you scan your clusters for the CVEs that you might have. So we'll just go ahead and integrate the Trivi just now. Yeah, so once you integrate Trivi, what it does is it creates a bunch of resources in your Kubernetes clusters, so that Kubernetes resources are actually analyzed by the Trivi that is running inside of your Kubernetes cluster. So we'll just wait a little bit for the Trivi to get started. So Trivi operator is there, it's creating, and let's just wait a bit. So now if I do integration list, you'll see that Trivi is active. And not just that, if I do filters list again, you will see that there are 2 more filters that has been added because of my integrations with Trivi. So I'll try to run analyze again with vulnerability report. I hope we get some output. Not so far. Okay, the pods are still not up and running. Still container creating. Okay, meanwhile it is running. What we'll do is we'll do another integration with Prometheus just to show that we can also integrate with Prometheus. And before that, we will install Prometheus quickly. So what it does is it to install the namespace. It already exists. And let's do the installation in that case. It's already installing. Okay, So I see that Prometheus installation has started, but it failed. Let me just uninstall Prometheus just in case. Okay, then let me do it again. Okay, so it has installed. Okay, so the when you install a Prometheus operator, it comes with a stack of both Prometheus, Alert Manager, and Grafana and everything. So that's good. And now we'll just quickly install the K8S operator. Already there. I already have created a secret. That's good. I'll just simply install the K8S GPT operator now. Okay. Okay, so your K8S GPT is also installed. So K8S GPT operator is installed. So you need to create an instance of K8S GPT from the operator, so that your operator will manage a K8S GPT instance. And I'll quickly create an OpenAI instance. Created. Now if I check the pods. Okay, so one is your K8S GPT operator, and then another one is your deployment, which is actually your K8S GPT that is responsible for talking with the AI backend. Here I have chosen the AI as OpenAI backend. I'll just quickly show you the YAML as well. So here you have to mention your backend as OpenAI and the model that you're going to use with the OpenAI, and you have to provide the OpenAI keys and secrets, right? So, and yeah, and once you have installed the K8S GPT, we just wait for the results. So your results are usually shown in when you do kubectl get results, and we can instantly see that results are already there. And the backend, it says that it is OpenAI. So what we will do is we will just describe one result to see what it says. So if I do, or we can do it JSON as well. So change the name of the result. Let's say I'll do this. All right. So you see right now the same details that you used to see in the K8S GPT CLI, you're seeing the same output, same results in your K8S GPT operator as well. It is outputting the results in your results resource in Kubernetes, and you see the details that it says it's coming from your OpenAI. So you can output this as a JSON or a normal human language if you would like, and then you can use it. You can integrate it with your other tools like Slack as well. And sorry. Analysis means, sorry, can you come again? Yeah. So the operator itself is deploying K8S GPT. All the logic that requires to analyze your cluster is inside your K8S GPT. So as I shown you, K8S GPT has itself. No, it will analyze your whole clusters. And in case of K8S GPT operator, you can still provide filters, but you have to change the YAML which you provide to deploy the K8S GPT. Right. And as I mentioned before, we can utilize Prometheus as well as Grafana. I'll straight away show you Grafana because that will show you a better UI. So what I'll do is I'll do port forward for Grafana. Okay, so I'll go to my localhost. Okay. Okay, and since we have used K8SGPT, we have enabled the Prometheus integration. You'll see that by default it comes with a dashboard for K8SGPT. So in this dashboard, you can easily see what currently results are there, which of them are like which are failing. Like for example, here 6 services have some issues, 1 pod is having some issue. Your overall analysis is 6 results, and yeah, you get a bunch of outputs here, and you can always integrate it with Prometheus as well. Based on what you want, you can change the Prometheus alerts, you can add Slack integrations, whatever you want to do, you can do it directly with your Grafana and Prometheus as well. All right, so I'll go back. So now I'll go here. So now, I mean, this is cool currently, but I'm integrating it with OpenAI. But what if I say there is one more integration that you can do with not just your OpenAI, but a local AI as well, which means you can run a local AI in your Kubernetes cluster or any other server, and then your K8SGPT can talk to local AI as well. So local AI is another open source tool which is available. You can deploy it anywhere, and it is a drop-in replacement of your OpenAI API. Right? You can, whatever API that you do with your OpenAI, you can always do it with the local AI. It uses your own data. Let's say you have a model that has been pre-trained based on your results, your outputs. You can always integrate that model with your local AI so that the results that you get is very specific to your own organization, right? And the good thing about local AI is it does not require GPU, it does not require internet. You can always use GPU acceleration, but yeah, I mean, by default, you can simply use your own CPU, and it supports multiple models. Today, I'll give you an example with Mistral. Mistral is another open source model, which is really good. And yeah, it loads all your models in the memory, which is why it is also very fast. It does not have to move, it does not have to load the models every time you give a call. So yeah, so overall architecture will look something like this. Your K8SGPT operator has created a K8SGPT deployment, and then your K8SGPT deployment has been told to check for a local AI instance, and your local AI is being backed with any of your model of choice. For example, it could be a Llama GPT-4 for all, or yeah.
Maybe you can share your
Okay.
screen.
It crashes, that's why I'm not sharing the whole screen. It's just one slide. I'll just go back to demo. Yeah. So yeah, you can use any AI of your choice, and that AI could be pre-trained on your own documents as well, right? So I'll just show you the demo for local AI as well. So I'll just install local AI. You can install local AI on your Kubernetes clusters as well. It has the Helm charts available online. Okay, so it's up and running. So what I have done is I have downloaded a few open source models. There is Meta's Llama 3, which was released last week. And then there's a Mistral also. I tried it with both, but Mistral gives a better response. That's why I'll show you with the Mistral today. And what you need to do is you need to give this model file, which is usually a gguf file, to my local AI so that it can load it in its module. So what I'll do is I'll just copy it inside of the local AI pod so that it can give the output based on my query, right? So to do that, I'll just use kubectl cp to copy it from my local to the Kubernetes pod. So yeah, I'll do it quickly. This is in my local cluster. The Kubernetes cluster that I'm using is my local. It is using Rancher desktop, right? So yeah. And so I've copied that model inside that pod. Now, what I can do is I can always port forward the local AI service that is running inside of my cluster, so that I can use the local address and the port to actually use my K8S GPT to talk to that API instead of talking to Open API. I'll show you how. I'll just run this command in another terminal. Okay. So now I'll use my K8S GPT to add one more backend, which is local AI. But this time I'll give the base URL as my local host on 8080, where my local AI service is running, because I have port forwarded the local AI service from cluster outside of the cluster, and then it's my local, right? So yeah. So I'll just add one more backend as local AI. I've given the name of the model as well as the base URL that will be used, but essentially it is using a local host. Now, if I do auth list, you will see that local AI is also active alongside your OpenAI. And now I can use the same K8S GPT analyze to actually analyze using the backend local AI. To see it is working, I usually go and check my CPU, because I'm running this model in my local. So of course it takes a bit of a CPU. So as you can see, suddenly my CPU utilization has increased, which means since my model is running on my local, the queries that it is asking, it is doing on my local. So hopefully we'll see a response in about a few seconds, because yeah, it's my local, it's a bit slow. Okay. Meanwhile, what I'll also do is I'll show you the Kubernetes the Kubernetes YAML that we are going to use to do the same thing as a Kubernetes operator that we did, right, using the local AI. So essentially earlier what we did was we used OpenAI and we used a K8S GPT operator. Now we'll use a K8S GPT operator to deploy a K8S GPT inside of my cluster that uses local AI. So essentially we don't need OpenAI, right? So in my Kubernetes clusters, I have deployed K8S GPT as well as local AI, and it will analyze the same cluster. It will talk to my local AI in the same cluster, and it will give the output in the same cluster. So essentially, I'm not going out of my Kubernetes cluster right now. 3%, okay. And here also base URL, which I'll be giving is from my local AI cluster, and inside of the local AI, it is slower than I expected. Okay, anyway, let's just wait for this one. Meanwhile, I'll try to open another terminal, and from here what I'll do is I'll apply. I'll first delete the other OpenAI instance just to make sure that we don't have multiple results. Okay, so I have deleted the other K8SGPT which used OpenAI, and also I've deleted all the results along with it. And now I'm installing the local AI K8SGPT instance. So this K8SGPT has been asked to use the local AI. "25 minutes? Oh my God. Usually it is a bit faster." Yeah, maybe because I'm not connected to my to a charger. That's why. Can you connect to the charger, Hitesh? So now you see that another K8SGPT. Now it should be better, I think so. Okay, so I've installed this local AI K8SGPT, and then I'll just check if I have results. No results so far. Just wait. Let me cancel this one. Yeah, it's very CPU intensive. Yeah, actually, my whole system is running hot. Yeah, usually it should. What I guess I've given a lot of queries to it.
I thought it's AC, so I just.
No, it's not AC. It's my machine. Okay, so I mean, we'll just to wait. So instead of waiting, if you guys have any questions, you can. Yeah.
GPT tuning portion, right? So this is just calling OpenAI on its own. If you leave it being a large cluster, you can make a million calls and back you up a lot of fees.
Yes.
What controls do we have on that?
So currently, there's an option of caching the results in case you are facing the same error again and again. What it does is it caches the result. It does not make the OpenAI call every time. In only case you have a new error, new issue, then only it makes a call. You always have the option to cache the results. There's no rate limiting as of now. You can always choose the number of frequency. Like if you're deploying a K8S operator, you can choose the frequency on how, let's say you want to check every 1 hour, every 15 seconds, every 20 seconds. That depends on you. But yeah, it has the option for caching that will probably save millions of dollars. And obviously, you have an option to deploy your own inference API in your local or anywhere else. Yeah, that is another option.
Does it also do anything with the response that is given to it by the model? Does it do anything with the response that it gets from the model?
It combines, basically your AI has a tendency to hallucinate, right? So once you, let's say if you are facing issues and you go to ChatGPT, you type I am facing this issue, and you'll get a bunch of reply which might not even be useful. But what K8SGPT does is it has exact prompts that it uses to make sure that it only gives you the required output, not a lot of other useless basically comments. And what it does is it combines both of them and gives you only 3 to 4 liners of recommendation. Right? So yeah, that's what it does.
It's modifying its prompt before sending it to the model.
Yes.
And after it gets a response, does it also do scrubbing on that?
I'm not sure about that. Maybe you can check it on the GitHub or a Slack channel to know that exactly what it does when it gets back the response. Yeah.
There's some work going on integrating with this Argo CD, right? It's a deployment tool where you can deploy on, you have a nice UI and you deploy the Argo CD, Argo rollouts. And at K8S, because the main part of Argo rollouts of CD is that you deploy the resources out, and if there's any issue, you see a graphical interface over there. I thought there's a work which is going on which puts out the data from K8S TBD and displays that. So when you get them, they call this page here in Argo C, the rollouts. You can display whatever commands that you got, whatever issues that you got. Any idea on that?
No, sorry, I have no idea if that is being worked on or not. But I would highly recommend you can go and check the Slack channel for K8SGPT. So while I was preparing for the demo, I had some issues and I went there, and it was they have people there to respond. And for any new features or bugs that you see, they highly encourage you to go there. So probably you can get more idea on if it is being implemented or not there. So for now, I'm not sure.
Yeah. So I know what the thing where the K8SGPT is being integrated to Argo CD.
Oh, okay.
And also Technon pipelines.
Oh, Technon pipelines. Yeah. Okay, that's good. Yeah.
Questions?
No questions? Let me check if it has given something. If not, then you guys can. Oh yeah, there are some outputs. Let me check. Oh yeah, now you can see, right? So what it has done is it has talked to the local AI and it has given the same set of output and results that you usually got with the OpenAI, and essentially everything that you see is in local, right? So it has given the error, like what is the error, and quick solutions. And currently it has been, and the model that I've used is basically a Mistral model, which is an open source model. So essentially now nothing has left. No data has left your cluster. Your K8SGPT is local, your local AI is local, and your model is also local. Of course, you can always use your own model which you prefer. But yeah, I mean, this is the final demo. Thank God it has worked. Yeah. Any more questions? So currently, local AI supports only few. I mean, the models that they support, they have it on their website. but usually a model should be trained on a you call it as a multi-modal model. And it knows a bunch of other things, not just specific things. So usually any LLM would do, but then again, you have to make sure that it has some knowledge about Kubernetes, and based on what you want to do it with it should have those knowledges. And I myself personally have tested it with Llama 3. It works, but there were few issues with the output that the Llama 3 was giving. That's why there was some, it was not working so well as it was working with the Mistral. That's why I'm just giving the output. I'm using Mistral. Yeah. Mistral is also really good. Yeah. Oh, okay. That's nice. Nice to hear.
Sorry, regarding the local AI, does it need to run in a machine that's visible from the cluster?
So for running local AI, currently I'm not use my GPU. So if you saw that, I only use my CPU, and I guess again using my CPU because it is in reconsideration loop. So as long as your Kubernetes cluster, if you are installing in Kubernetes cluster local AI, if you're installing Kubernetes cluster, it just needs a CPU. But there are a few requirements of the CPU that it should have minimum this much of CPU. You can't use T2 micro and run your local AI, right? You need some some CPU. You don't need to expose anything as such. Just being a default Kubernetes cluster with the CPU will work.
Because I do not want to run the LLM on my cluster.
On your own cluster at home? Is it a home lab?
Okay, so for example, like can you run on a machine that's visible to the cluster but external to the cluster, or as well as can you run on a machine that's only visible from like console?
You can have a cluster anywhere. In the cluster or outside. I run it personally on my mini PC, on the
The K8 GPT, right? So yeah, if you're in K8 GPT, let's say in your local without Kubernetes cluster, there's option to run the local AI without Kubernetes also in your local as well. So essentially that K8 GPT can talk to local AI, not running in Kubernetes, but anywhere else. You just need to provide the backend URL which you want to use. Yeah. Any more questions? Okay. Thank you so much. I'll be around. Just let me know.
Thank you, Vishnu. I hope this session was again wonderful and you guys learn something about K8 GPT. We are done. However, before we move, we would like you to give us feedback. Can you guys see the screen QR code? Oh, this is it's okay. So I would encourage everyone who are standing there at the cafeteria as well, please scan the QR code. I would request everyone to whoever are there, please scan the QR code and give us the feedback, because your feedback means a lot to us, for us to understand if there is something that need to be improved, so we can do that much better in our next meetup. I hope everybody scanned the QR code and gave the feedback. Now is the quiz time. So today we will have a short quiz, and there would be only 6 questions. And as many of you know, the winner of the quiz will get something. But today it's like the first 2 winners will get Code Cloud access for 6 months, full access for 6 months. for first two winner. So let me move on to the quiz. Is it too small?
Yeah, yes.
Is it okay?
Very small.
Don't worry, the questions are going to come on your mobile, so you just have to scan the QR. And yeah, again, don't look at the screen for question and answer, look your mobile, okay? So or else you guys will miss it and then you won't be able to. So start the quiz. Now QR code will come, so you will get 15 seconds. There are 6 questions, 15 seconds each. Start the quiz. So it should not ask you any sign in or email, it's a guest. So you should be able to just go and access the quiz. Huh? I think it should not ask you for the code. Is it asking code for everyone? Scan the QR, it should not ask you the code. It's good, right? If it is asking code for anyone, please again scan the QR code. I'll wait for another 10 seconds. Everybody join. All right, we have 16 participants, 18, 19, good. Right, so I'll start and I'll click the first question. So you will see the first question on your screen in 5 seconds. Which one is not a key feature of OpenKruiseGame? Network automation, hot update, game development IDE, customized QoS, 1 and 2, 3 and 4. All right, game development IDE. Naveen, right. Right, move on to next question. Which of the following statement is not true? OpenKruiseGame is a child project of OpenKruise. OpenKruise is Alibaba open source. Support IEP, EIP, SLB, NLB, SNAT gateway. Answer 1 and 2, 3. All right. Move on to next question. Which command is used to add backend like OpenAI, local AI in K8SGPT CLI? Question 4. Which command is used to analyze only pods in Kubernetes cluster with AI while keeping it anonymous? Fifth question. When using K8SGPT operator, which command is used to fetch the K8SGPT analysis result? kubectl get results. 13. And now the last question. Which of the below tools can be used to run open source LLMs on your local machine without GPU or internet? All right, local AI. And with that, we are done with the quiz, and the winner is Naveen and JHT. Who is JHT? Okay, so after this, you guys give your email address to Fazil. Okay, and we will share across the code for Code Cloud for 6 month subscription. And before we go, I would request everyone to please come here. We'll take a group photo as usual before we going, and then you guys can take a leave. I would request everyone to please come towards the screen.